The goal of this project is to get the NPC to recognize you and follow you wherever you are. You will hit him and he will recognize that you're in range and start following you. If you escape his range, the big red area around the NPC, he will retreat back to his previous wandering position. This is usually pretty normal behavior you notice during an RPG or an MMO when you attack a creature and they return back home. They usually retreat back home due to being out of range of the player or because they are too far away from their spawning position. Either one works. Then you can do other neat things like recover or interfere with them if you wanted to. Now, if you wanted to download and play with this project will be accessible via my GitHub. Link will be in the description, along with a README file with other helpful links and resources that you may need to get the project started. Now, a couple things we will learn is 1. How to use BDPro events. 2. How to use subtrees. 3. How do aborts affect BDPro events. 4. Further Blackboard examples. And 5, switching between different actions, meaning switching between an NPC wander and to a chase. It's important to note that you don't need the wandering scene to do this tutorial, but you can pull this from the GitHub repository and copy this yourself if you would like. A couple assets that you'll need will be the Unity Starter Assets Character Controller, Behavior Designer Pro, and the Unity AI Navigation. There will be helpful links in the repository and in the description. And now, to get started, I am quickly going to duplicate my BP wandering scene and create a new BP chase scene. Then I will disable my red cube and rebake my NavMesh to create a separate NavMesh from my wandering scene. Next, I will create a new scripts folder called BP NPC Chase and create 3 new scripts. The first script will be ChaseTarget, whose job is to chase our player, NPC Receive Damage, which will trigger when our NPC receives any kind of damage, and finally a constants file, which is for our constant variables. Next, I'll create a NPC wander subtree. I want to move all of the BD wander nodes into its own subtree to keep my BD tree a bit cleaner. I'm going to select all of my nodes under sequence and copy and paste it into my new subtree. I now need to copy my graph variables into my new subtree. These are reset wander, has reached destination, and can get new destination. Make sure reset wander is checked as true. Now I can delete my red cube behavior tree nodes, create a new subtree node, and assign my NPC wander subtree to it. Make sure to assign your reset wander Blackboard variable for reset wander to your subtree. Otherwise, you will get some interesting behavior. And delete the 2 other shared variables from the parent. You don't need these on the parent, but we'll need it on the child. One more thing to do. We want to show the mouse cursor, so what we can do is open the starter assets input.cs script and comment or delete line 71 and save it. The Unity character controller hides the mouse cursor, and in our testing, we want to show it instead of hide it. After saving it, we can hit the play button and see that the NPC wander behavior tree is working the same as it was before by checking the behavior designer graph and observing the NPC in the Unity scene. Once we verified it's working correctly, we can move on to our ChaseTarget script and get started. Let's clean up the script before we get started by removing all the mono behavior code and adding the behavior designer onStart and onAwake methods. The goal of ChaseTarget is to chase our player when the NPC is aware that there is a target to chase. We're going to feed the player target to the NPC and have it chase down the NPC as needed. We're going to create a ChaseTarget object method to do that. We also need to create a stopping distance method. The stopping distance is used to determine how far we can be from the player before we stop. If we don't create one, the NPC will constantly try to push the player to get to its XYZ coordinates. Here's how determine stopping distance works. This script will be a node on the NPC behavior graph. So we're going to get the NPC's parent position and find the difference between this NPC and our target. Then we're going to try and find the direction and distance between the two. If our current distance is greater than our stopping distance, we want the NPC to continue to move forward towards the player. One last thing, we need to set our parent reference in the awake function before we test. Now we can switch to our queue behavior tree and search for the chase target node that we just created. Add it as the first node in the sequence, then right-click our NPC Wander node and disable it. We only want to test the ChaseTarget node. As the project's running, we're going to drag our player character to our target object. If you notice, the red cube is going to start pushing away our character as it starts to approach it. And that's because our stopping distance is set to 0. I'm going to set this to 2 units, and it should give us some buffer space between the player and the cube. Now I'm going to try 3 units just to see how it looks real quick in the scene. Then back to 2 units. Okay, I'm going to stop playing this and set the stopping distance to 1.5 units, and if we need to adjust this later, we can. We have a working chase scene for the NPC now. However, we need to give the player the ability to escape from the NPC. Think of this like an invisible leash. Once the player moves beyond the set distance, the leash breaks and the NPC stops following. Let's start by creating a shared variable float of leash distance, which tells us how far we can go before the leash breaks. Then we can add our code. If is within leash distance, return success. Otherwise, unassign the target and return task failed. Is within leash distance will measure the distance between the NPC and the target. If we're within range, return true, otherwise return false. We're also going to add onDraw Gizmos and create a draw area wandering. This will be a solid circle that will revolve around the NPC as the NPC moves. Also, as a version 2.0.9 of Behavior Designer, we no longer have to enable Gizmos manually. Now, let's give this a quick test run. I want to make sure the red cube is slower than the player to make the test easier. So I'm going to select the red cube and adjust this NavMesh agent speed to 2. Then I will assign my player armature as a target object. The red cube should start to head to the target's location. However, as I start moving the player, the red cube does not follow anymore. Now if I try this again, but with the red gizmo we drew, we should notice a change in the AI's behavior. That's because we were out of his leash range. The frame where the player is assigned was assigned to the destination the first time, then lost it when the target got unassigned. However, if we stay within the leash range, the NPC will constantly keep chasing the player until we run outside of the leash range. For this next part, we need some way for the NPC to react to the player and approach the player on their own. We're going to add a collider for the NPC and the simple projectile from the player. The projectile will contain information about the player game object, and when the projectile hits the NPC will be aware of the player and starts to follow the player. We already made our NPC receive damage script, we just need to make our projectile shooter script as well. We also need to add our bullet info script. In our constants file, let's add tag damage object, which will have a reference to the bullet. And in the bullet info, add a game object sender so we know who sent the bullet. In NPC receive damage, we need a reference to our behavior tree to alert our tree that the NPC has been hit. Then we can create our trigger enter, which we will go over in a second. Also, we need a reference to the OPSIB shared events. First, we want to create a guard class. We only want to recognize the object with the tag damage object. Second, we want to verify that the bullet received contains the bullet info class. If we don't have it, we want to log an error response just in case. Third, we need to call our event handler. This will send an event to behavior tree with our sender info. And fourth, once we're done with the object, we can destroy it. In Unity, we need to add a receive damage child game object. We're going to add a sphere collider to this game object so it can receive our bullet. Make sure isTrigger is enabled for our collider. Also, add our NPC receive damage script we just made as a component. Change the radius of the sphere collider to 1. Now we need to work a simple projectile shooter script to spawn and make the bullet go forward. We want this to trigger on left mouse click and fire. We then need a raycast from our camera to our mouse click. The aim layer mask will be left as default. We then need our hit info target and determine our direction towards the target. Then determine our spawn point. We can use fire distance from character to give us a bit of space between us and the bullet. Then spawn our projectile and launch it forward using the rigid body velocity. The projectile speed is used to determine how fast it can go. One last thing, we need to add our bullet info to the bullet as it launches forward. Now, let's switch back to Unity. In Unity, I want to create a projectile spawner child object, then add the projectile shooter component that we just created. I'm going to create a new sphere 3D game object in the scene. This will act as our bullet. I will also create a new Unity material and make it yellow. Then assign this to our bullet so we can define it a bit easier when we run the game. We can then switch to our bullet game object and add a rigid body to it as well. Next, if we drag and drop our bullet to our prefabs folder, it will then create a new bullet prefab we can then reference. Once that's done, switch to our projectile spawner and drag and drop our new bullet into the projectile prefab slot. This way, it will create the correct bullet prefabs. I'm also going to drag and drop our player armature into the prefabs folder to create a prefab variant of this as well. It's not necessary, but I like to have the variant different from the original in case we change anything unusual. A few more things we still need to do. Aim layer mask is set to nothing. We need to change this to default. Then head to our bullet and drop down the tags. We need to create a new tag of damage object. Then head back to our bullet prefab and assign it to the damage object tag. We can now do a quick test run and check out if our left mouse button is responding and creating the bullets we are expecting. As we can see, the bullets are created correctly and projecting forward. Let's work on our behavior tree next. The NPC can receive damage and notify the behavior tree, but we need a way for the tree to respond. By the way, I will explain how this works in the end. We can start by adding a has received event node. This will act as our event receiver. Now, our event will continue to fail until it finally receives an event. So to prevent it from failing, I'm going to add a return success node, whose job is to return success even if it fails. Now, on the left side of the tree, I'm going to add a game object comparison and a sequence node. The game object comparison is going to check if we're missing the target object or not. Then I will assign our compare and ChaseTarget nodes to our new sequence. Then I will delete our original sequence and replace it with a selector node, so it will either run the left side or the right side of the nodes. One last thing, it's possible that our target object will be missing and our event will return true. We only wanted to run the chase logic if the target object is not missing. So we can do this by adding an inverter node. I will then add our target object to our list of graph shared variables, aka our Blackboard variables. We can now assign our target object to our nodes. First, the ChaseTarget node. Second, our game object comparison node. On has received event, we also need to give it its event name of on received damage and assign it the target object node. Now, how does this all work? First, the player will attack our NPC, which will then receive an on received damage event. Once this event is received, the target object value will have the player assigned as a value. Now, on the next iteration, the selector will run the game object comparison node, which will find that the object is no longer null. This will then call our ChaseTarget, which now contains a reference to our target object. Since it has a reference, it should then chase a player as long as they are within the leash distance we set earlier. We should be able to give this a test run now. When the game starts, I'm going to head to the NPC's leash range and try to attack them. We can see that the bullets are being received and deleted, so the receiver is working, but the NPC is not reacting at all, even though we can see the behavior responding in the behavior tree. This is due to two settings established in the documentation on how events work. In the Behavior Designer documentation, it mentions two things. In order to properly receive the events, the has received event task should be reevaluated with conditional aborts. And the second, during the first tick, the has received event task will fail because the event has not been received yet. That means we need to set an abort setting to our sequence to allow events to be properly received. We also need a task afterwards to respond properly. Normally, this would be our wander node, but if you don't have one, you can use a wait node as a substitute. Now, if we run another test, it should work. But if by off chance it's not working, like it is on mine, check the spelling of your event name. The event name is case sensitive and should match up to what you have in code when we first wrote the NPC receive damage script. Now that the name is correct, we can hit play and try again. I will head to the NPC's leash range and see if he responds. Now that our NPC is responding correctly, wherever I go, I should be able to head left, right, north, east, and eventually run outside of his leash range, which he should then lose me as a target. If you have the NPC wander node from the previous tutorial or from the open GitHub project, you can switch out the wait node for the NPC wander node and run the test again. Head over to the NPC's leash range and start attacking them. They should start to follow you, as long as you stay within the leash range wherever you go. Then, when you walk outside of the leash range, the NPC should start to wander again. Now, if by the off chance your NPC does not start wandering, that's due to the reset variable of the NPC wander behavior tree. We can fix this by opening our ChaseTarget script from earlier and create a new method of reset variables. In reset variables, we will unassign our target object and set our reset wander to false. Also, add our reset wander as a shared variable boolean up top. Back in Unity, we can select our ChaseTarget node and assign our reset wander reference from Blackboard and test. When we run the project again, we should be able to approach our NPC's leash distance and attack them to get their attention. The NPC should start to follow us again, regardless wherever we go, until we eventually run out of the leash range. Once we run out, the NPC should go back there to the next wandering position inside of their wandering area. I should be able to attack them again and escape their leash distance again without any issues, repeating this process over and over. Now, if you like this tutorial, be sure to give this video a thumbs up and subscribe. It really helps out the channel and helps me make more content like this. If you're looking for any more references in the code or would like to pull this yourself, feel free to check out the GitHub repository and read the README in the GitHub repository to run this project yourself. Thanks again for watching, and I'll see you guys on the next one. Laters.